So I will just present what kind of challenges and opportunities we have looked into. So the main challenges for nanosatellite mission are how to go there, how to go where we want to go, how to communicate, how to survive, and how to demonstrate the usefulness, how to convince people about the useful of nanosatellite. So first of all, how to get there. So we have been discussing about several possibilities. One could be to be in a GTO orbit and then go with our own propulsion system. Use an interplanetary host mission, or use solar cells, or electrical propulsion, but this will be actually just for small attitude correction or orbit correction or attitude control, not to go there. And why not later in the far future some concept from ISS. Then how to communicate. So one thing could be use a laser, but it's still a very early stage, and the pointing accuracy needed is will be too high to reach at this stage. Also X-band or Ka-band communication, or why not using satellites over satellites or rovers as a data relay to the Earth. Ground station, maybe future ground station on over celestial bodies, or what we call the Hansel and Gretel configuration. So you just like disseminate your small satellite all the way on your trajectory and use each satellite to do to use it as a relay. Then how to survive. So the main problems could be thermal issue. So it depends if you go towards the sun or away from it. And radiation, also radiation and degradation of materials. So some specific shielding, specific protection for each component could be imagined. Also, micrometeorites is an issue, and again, shielding could be useful, but shielding on nanosatellite is not the easiest thing to do. And also, another problem could be the internal clock shift, because if you have a satellite which is not able to communicate very often with Earth, the internal clock will shift. And if you have an autonomous navigation, for example, that could be a big issue. And I don't have solution for that. Then, how to demonstrate the usefulness. So basically, three field could be useful. So one, the science. The science in if we think about different way of doing it. Not the way we do with big satellites, but with small satellites, new contact missions can appear, and also using it as a precursor. A precursor for example, a big scientific mission, which has to demonstrate a certain theory. A small satellite could be used to demonstrate the usefulness of the big mission. Technology demonstration. So technology demonstration for bigger mission or for a network of satellite. Before sending a lot, you just send one and you demonstrate the technology. Or business, because nanosatellites are more affordable for privatization than big ones. So what kind of opportunities in each of those fields? As I said, for the science, we could get like multi-site measurements and at the same time, and also the frequency of the mission could be higher. And if we use satellite like bullets, if we lose a nanosatellite, it's less important than losing a big mission. For the demonstration, so technology demonstration or scientific demonstration of bigger mission could be thought. And for the business, easier privatization. So why not advertisement, marketing, selling the space meteorology data, interplanetary communication, or space test platform. So to conclude, yes, there are many challenges, but also there are many new opportunities which are coming. And I think the goal is not to prove that nanosatellite can do the same or can do better than a bigger mission. I think the goal is to prove that we should rethink the way of doing a space mission, and nanosatellite could do different things. Not the same, not better, different things. And I think that's in the direction of the thinking. So I would like to thank everybody who joined today's discussions, and I would like to thank you all for your attention.
The next presenter is